Welcome to lesson 12-4. We're still analyzing data in this section, and today we're going to learn how to make a stem and leaf plot. The last lesson we learned box and whisker plots, so now it's stem and leaf plots. So lots of fun names for these lessons. So we're going to be making these stem and leaf plots, and then we're going to use them to compare data, just like we did with our box and whisker plots. It's another graphic organization to display numerical data arranged in order. So each data item is going to be broken up into a stem and a leaf. So say, so the stem is the digit. So if you have the digit 10, right, this is just one of your numbers in your set of data. That's the number 10. The digit on the left is going to be your stem. You're going to have a line dividing your stem and your leaf. And then the digit on the right is the leaf. If I had the number 5.25, there could potentially be that I divide it this way, so the 2.5 would be my leaf, and the 5 point, and just the number 5 is my stem. I could also potentially divide it if I had 5.25, 5.2 as my stem, and then just the single 5 as my leaf. You'll divide, put this divider line as your stem or leaf based on, right, this divider line here is going to be added, put in between different digits based on just a set of data you have, right? So if you had, say, also the number 5.26, 5.27, 5.25, it's going to make sense for you to do the 5.2 and then list your either 5 or 7 or 6 on this side as your leaf, as opposed to repeating for each number, because that's the only difference, right, in this data set is the 5, 6, or 7. So that's where you would be breaking from a stem to a leaf. I'm going to go ahead and do an example showing how we do this, the steps for making a stem and leaf plot. It'll make more sense as we go. So first of all, we need to choose our stems. If this is my set of data, the prices of digital music players in dollars, all these different numbers, we want to look at the difference between them so that I can choose what my stem is. So the least value is 189, and the greatest value is 214 is the greatest. So for this data set, we're going to use the first 2 digits as the stems. So step 1 was choose your stems. Step 2, we're going to draw a stem and leaf plot. And you must always include a key. So a complete stem and leaf plot is going to look something like this, where I have so on this side I have my stems, on this side I have my leaves. So if I'm doing two-digit numbers, my stem is like 18, 19, and 20, and 21, right? Because I go from 180s up to 190s, 200s, and 214 is my highest. So I'm in the 210 range is my highest. So those are my stems. I'm going up by 10 digit increases. My leaves on this diagram are the last ones place number. So 189 is my lowest number. So I'm going to use that as an example of for my key. I'm going to add my key here to the bottom. I'm going to say, my key is that 18 line 9 means 189. That way someone looking at this can tell, okay, what is the difference between, why is there space in between my 18 and the 9? Are those just two different data sets, or are they different numbers? Are 18 and 9 separate numbers in this data set, or is it 189? So I'm telling them with this key, 18 with a line then 9 means 189. And it's in dollars, so I'm going to put dollars. $189. So for my other leaves for 19, I have 190, just 190. I'm going to have a space. You're going to put your leaves in increasing order. That is a note here. Right, leaves in increasing order. So 190, 192, 193, 194, 195, 195, there's a second one, 196, 198. So now I've got all my 190s written, right? I've done my 189, I've done 192, 90. I've got all of this taken care of on my list. I'm going to do my 200s. There's just a straight 200, and there's two 201s and a 205. So 200, 201, 201, 205, 208. I have 214 and 211. 211, 214 as my 20 off my 21 stem. So now I've listed my entire data set on this stem and leaf plot. I've gotten all my numbers on there. So it goes from smallest number, 189, up to my greatest number is 189 is my greatest. Or my smallest, my greatest is 214. But so you have to look at the stem and then the leaf in order to get the final, to know what a number is on this diagram. So looking at that key is really important. It says 19/1s means $189. That means that also, like, 21 /4 means 214, or 20/1 would be 201. Alright, I'm going to have you go ahead and make a a stem and leaf plot for the high temperatures in Death Valley, California. Go ahead and make a stem and leaf plot for this data. Pause the video once you have it. Hit play to check your answer. Alright, you should have picked, for this stem and leaf plot, that the number in the tens, or the tens and hundred place, is going to be your stem, and then the number in the ones place is your leaf. Right? So you would have listed your stems, 8, 9, 10, 11, 12, 13, because we go up to 130, and our lowest number is 86. So we'll list 8/6. Our other ones place for the 80s is 87. And then we have 91, 97, 101, 111, 113, 120, 120, 105, 106, 120, 125, 126, 134. And then your key, you could have picked any of the numbers as long as you put what's in the stem /1 means, and then write the number all together, like 10/1 means 101 degrees. Make sure you put the degrees because we're talking about temperature, degrees Fahrenheit. Could have even specified that, degrees Fahrenheit. So you must include a key for every stem and leaf plot that you do. Right. A way to use stem and leaf plots in order to compare data, we make what's called a back-to-back stem and leaf plot because it shows two sets of data on the same graph. And that side-by-side display makes it really easy to compare the data visually. And it makes it easier to almost like see the median and the mode of a data set. So we're going to do an example and see how to make a side-by-side plot and how this can help us compare information. So here we have the winning times in the Olympic 100-meter dash in seconds. We're going to draw a back-to-back stem and leaf plot for this data, and then we're going to use the median and mode in order to compare the data. So our first job is to make a stem and leaf plot. So in order to do that, we need to, because it's going to be back-to-back, we're going to have the stem in the middle, and then we're going to have our leaves be on the two sides. So the two things we're comparing in this case, we have men's time, we have the time for men, and we have the time for women. So we're going to list and compare the time for men and women. Do men, and then women, and then our stem. So our stem, let's look at the seconds. That's right, the number before the decimal place. So stem can be in seconds. So we'll list like our smallest number of seconds is 9. Then our largest number of seconds is 11. So 9, 10, and 11 are stems, our number of seconds. Now for the men and women, we're going to be putting tenths of seconds as the leaves. Tenths of seconds. All right, so that's the decimal places that we're looking at now. So we're going to go ahead and we're going to have a key on each side. A key for each. Whoops. I'm going to actually leave a little space there. So say like 10, 1, 10, 5. On this side, that's going to mean 10.5. Coming over to this side, 1/10 is going to mean 10.5. So on the men's side, on this left side, the tenths of second is being listed first, but that's still talking about tenths of seconds, so it's still going to come after the seconds when we write it out as a number. So even though this 1 comes first, as we read left to right, it is still talking about tenths of seconds for men. So we go from the seconds over to the tenths of seconds. Same for the women, seconds to tenths of seconds. Let's go ahead and fill this out. So for men, we're going to start with our greatest time first, in terms of the 9 seconds. So 9, we have 9.9, 9.9, 9.9, 4 of them. So we need 4 9s listed. So 9, 9, 9, 9. We also have 9 8. 9.8 seconds. For women, there's no times in the 9 seconds place. So we're going to go over to 10. Now for men, we have 10.1, 10.1, 10.0, 10.2. Our greatest time in the 10-second place is 10.3. So we'll go 3, 2, 1, 1, 0, 0, 0. 3, just flat 10 seconds. Now for the woman, we have, we're going to start with 10.5. So our smallest, 10.8, 10.8, 10.9, 10.9. Now we're going to move over to our 11s. We have 11, 11, 11. So 0, 0, 0. 1, 1, 1. And then 4, 11.4. All right, so now you're that you have your stem and leaf plot done, we have our key on here. We can compare these two sets of data. So this kind of gives the impression, when we just glance at this, that the winning time for women here is greater than the winning time for men, right? The winning time for men is overall lower, right? There's more numbers in the lower category, and then the women, the numbers are in the higher category. So women, their winning times were greater, larger numbers than for men. It's also kind of easy to glance at this and find where the median is, right? You count backwards from each side. The median for oh wait, I counted that wrong. Median time for men is going to be counted from, let's go here. Go 9, 3, so 9, 8 is our smallest time, so we'll start 9, 9. 10, 3 is the greatest, so 9, 8, 10, 3, 9, 8, or 9, 9, 10, 2, and kind of tally our way through so that we're left with 10.0 seconds is the median for the men. For the women, 11.4 and 10.5, 10.8, 10.1, 8.1, 9.1, 9.0. So 11 seconds, 11.0 seconds is the median for women. So just by glancing at this, you can tell visually that the winning times for men or for women are going to be bigger numbers. And then you look at the median for men and women, and you see that the median is 10.0 seconds for men and 11.0 seconds for women, so that's a whole second higher for women as the median or middle number. You could find the mode. The most common number for men is 9.9. for a woman, the mode is, well, either 11.0 or 11.1. And that tells you just overall that by looking at these different measures of central tendency and looking visually just at the graph, you can make the conclusion that the women's winning times tend to be greater than the men's winning times. So the women tend to be slower overall in terms of their winning times. So this graphic representation helps us to more easily just glance and see the difference between the two different sets of times, the difference between the men and the women's winning times. So it's just another way for us to analyze data. All right, so I'm going to have you practice this now. So make a stem and leaf diagram, a back-to-back stem and leaf plot, showing videos and CDs and their sales in terms of millions. Now this is the same set of data that we analyzed with our box and whisker plot, but this is going to be a different graphic representation. So you could go back to your old notes and kind of compare and see what they look like once you've done this. So hit pause on the video, go ahead and make your back-to-back plot. Once you're done, hit play to check. Alright, you should have decided, you should have lined up your stem and leaf plot with your stems in the middle, your videos and CDs on the sides, as long as you labeled it and as long as you put the numbers on the correct side. It doesn't matter if you put videos on the left or CDs on the left, and vice versa. So for your videos, you should have had 17, 16, 15, then 28, 24, 24, 22, 22, 21, and 30 as your listings. CDs, it should have been 15, 16, 16, 16, 17, 18, 18, 22, 24, 25. Should have had a key that had shows that your tens place begins on the left, so that 0/1 means 10 million, and so that 1/0 to the right means 10 million for the right column. So you do need a key showing that in both directions, both columns, what that information is going to look like. Alright, your in-class assignment is page 625 in your textbook. I want you to do numbers 6 through 10, all of them. And your homework is 12-4 in your practice book, the workbook page. Remember that there are multiple ways to solve a problem. So if a problem asks you to find median or mode, you can put the data in order and numerical order and count backwards in order to find the median or mode, or look for the mode, the most common number. Or you can make a stem and leaf plot. This could be one way for you to easily visually see the median mode. It helps you organize the data in order to find those measures of central tendency. So this is just another tool in your belt, another way for you to find measures of central tendency. So in your homework there may be some problems where you could choose which way you want to put the data, which way you want to represent the data. There's always more than one way to do a problem.